This is the Rollomatic Smart Factory. Here we have the ERTmiral webpage. This is the sort of command center for our robots. Here you can see we have 2 robots in our fleet. Here you can see the status of the current jobs and the total completed jobs today. Then if we move on from this overview page, we can take a look at our 2 fleets. One is a M14 robot that is currently working. You can see his battery level, see his payload that he has made up of a TM arm and an LD. We also have the Smart Factory fleet made up of the M20M working, battery status at 70%. We also have the interface for the Rollomatic machines. So this is how we create the handshake in between the robot and machine. The robot will request access to open the automatic door on the machine. Once he can confirm the door is open, the robot is ready to load the pallets into the machine. You can see the connection status. You also, outside of the job, would have the option to manually open the doors from here in ERTmiral. Here we can see the current job status. These are previously finished jobs. We have 2 running right now. You can see which step of the job you're on, 1 out of 9 or 3 out of 8. Which robot is doing the job, who's authorizing it. This one is authorized by an API key. If we want to see what's going on inside that job, we can look at our process flow graph. So this is all block flow programming with pre-programmed modules. LD3, that would be coming from the program of the AMR. So it knows which goal to go to here. So you say, go to goal of 630 XW machine. Then you want to run TM4, that is a pre-programmed job for the cobotic arm on top. So he says, drive to the Rollomatic machine, then start to load the pallets, and so on and so forth. So you can easily manipulate and create new jobs and new process flows just within ERTmiral without having to jump into the robotic programming. All right, so here I'm going to create a new template for the robot in ERTmiral. So here I can create a new template for process flow. So first, we want the robot to drive somewhere and then do a job. So if I just drag and drop an LD block node, here I can select where I want him to go from my pre-designated list of goals. So we can go to the 630 machine, the smart shelf, the upper or lower station, or you can go over there for the bin picking session. These are completely flexible and customized to the customer. So on your factory floor, we will preset the goals, and from here you just select where you want the robot to go. So I'll say, go to the 630 machine. Then I want the TM cobot to do a job. So I can say, pick at the 630. Then I can ask him to do a wait based on a parameter or based on a certain time. I can even ask him to then drive back to the smart shelf and then unload the tools. Now all I have to do is connect my nodes, publish, and now I have a new job ready to be sent to a robot. So we can communicate directly with the machine or other machines through our machine tending plugins. So that's how we request access from the machine through different communication protocols. And then also through the REST API is how we would connect to the customer's MES system. So the actual material ordering can come from a customer's existing MES system and then be implemented into an ERTmiral job. And then we can use the machine tending plugin to interface with machines on the factory floor.
Like beta testing, or you have quite a customer base?
We already have them in production. So we service, obviously, Rollomatic customers with the Smart Factory, but other industries as well. Life science, automotive, pharmaceutical, injection molding, very broad. And the idea is to create a flexible solution, a robot that can work in a lot of different conditions and do a lot of jobs. And we specialize in the last mile of production. So you might already have automated solutions, but how does material get to and away from your production line? The answer to that could be Mobert.
How many of these would a facility possibly have of these robots?
It depends on their needs. So one Mobert could do in total, possibly up to 10 machines, maybe more, 3 to 5 range for depending on your throughput for the cutting tool industry. Outside of that industry, it's really going to depend on how your production works and how often you need the automation to tend to each machine or move between stations.
And then you could say like, wait till the machine gives like a done signal, and then pick part.
Yep, the machine will say, I'm done, I finished my production, and then call the mobert over. And that higher level communication is done by the MCS. So for this system, we're using Soflex for that material handling. And that also allows us to communicate the measurement data. So if you throw it into an automated measuring machine, we can send a program to be run for that specific tool that has just been ground. And then that measurement data can go to the Rollomatic machine. So you can automatically create offsets to make your tools still in tolerance without any human intervention.
So you can see if there's a drift going on and then
Exactly.
correct for it.
Yeah, and compensate for things like grinding wheel wear. And of course, we can track all this data to see if there is certain trending things, for example, temperature changes. What we're doing is measuring the tool and seeing where it is relative to the nominal dimensions of that tool. So if it's outside of tolerance, let's say the tool is oversized in diameter, you can make a wheel offset and send that to the machine so the next tool comes back in tolerance, right? Over time, your grinding wheel is going to wear down. That's going to happen. An operator now would just go in and make a quick offset. The tool stays in tolerance. But let's say it's the weekend, the operator's gone. If you ask Mobert to bring the tool to the measuring machine, then he can automatically send the corrections without operator intervention. It's actually would be the MCS system, which is sending the corrections back to the Rollomatic. We make a program on Soflex, the MCS system that we're using. The program would say, start at the smart shelf at this carrier position at the smart shelf. So grab this order, take it to this machine, the 630 right here, run this program on the 630 machine. Once you've run 10 tools or however many tools, then send the robot to measure a single tool at a measuring machine. The measuring results can then be pulled by Soflex and given to the Rollomatic machine. Based on those results, it's automatically making the correction and keeping the tool in power. In the Soflex MCS software. So here you have the organizer. It's showing what is going on in each station. And here you create, through the organizer, a production order. So you can have pre-made programs. Let's say we do Open House 2025. Give it a name. Give it the number of pieces you want to produce. And then once you create it, you just can assign it. It will be automatically assigned eventually as well, but if you want to move a little quicker, you can assign it to a station on the smart shelf. Then once it's created, once the Mobert is free from his last job, he's able to go pick that from the smart shelf and take it to the machine. In this current program, we don't have the closed loop measurement, but that's something that we've shown at EMO this year, as well as IMTS last year. And it's working through all the same softwares and systems and same communication protocols. We can also do error handling in ERTmiral. So let's say something happens and the robot cannot find the landmark or he has some issue. We make all of our robot programs with step logic. So therefore, once he runs into that issue, an operator can come in, assess the situation, and make a decision based on 3 possible options. He can say, there was something covering the landmark, so the picture failed, and retry the commands, see that it's successful, and the robot continues working. You can say the command failed, so for some reason that machine is maybe inaccessible, maybe it's down, or there's an operator using it. So you can say command failed, and then the robot is free to do other jobs. Or you can tell the robot that he is incorrect and the job is actually successful, and he can go on continue with his current job. Whenever you have technology and humans working together, automation and humans, mistakes can happen. So we really prioritize safety. And by adding in that error handling, you don't have a robot to continue working in an incorrect way, because that's not only unproductive, but it can also be dangerous. So here we have the opportunity, and very costly. So here the operator has the opportunity to assess the situation and easily communicate with the robot on what he should do next without having to do a deep dive into the actual robotic program.